This video goes with Unit 7, the mole. The essential questions are: what is a mole, and how can we use the mole in chemistry, and how can we find out how many representative particles are in a sample of a substance? So the mole represents this number. It's a really big number, and we abbreviate it with scientific notation, 6.02 times 10 to the 23rd. You'll want to know that number by the end of this unit. That's equal to 1 mole of any element or compound. Just like a dozen is always 12 of whatever you're talking about, a mole is 6.02 times 10 to the 23rd for whatever you're talking about. So 6.02 times 10 to the 23rd, and that's representative particles, which means that could be formula units, which is for an ionic compound, atoms, ions, or molecules, which would be for a covalent compound. And Avogadro is the one that came up with this. He was a scientist, and this is called Avogadro's number. So if you think about how big a mole is, it's really, really big. So for example, it would take 19 million years to spend 1 mole of dollars if you were spending $1 billion every second. That's a lot. A mole of sheets of paper would stretch to the moon and back 80 million times. A mole of baseballs would fit into a bag as big as the Earth. A mole of rice grains is more rice grains than have been grown since the beginning of time. So this is a really big number, and we use it to talk about really, really small things. Okay, so we're going to look at how to convert. We already talked about dimensional analysis, so we're going to use that. So we're going to go between moles and number of particles, which could be atoms, ions, formula units, or molecules. So for example, how many moles of carbon are in 2.5 times 10 to the 22nd atoms of carbon? So I write my known, which comes from the problem, and I draw my railroad tracks. Okay, atoms is on the top, so I need it to go on the bottom next time, so it'll cancel out, and I'm going to have mole on top. So 1 always goes with the mole, and then atoms is going to be that number, 6.02 times 10 to the 23rd. That's how many atoms there would be if there was 1 mole. Well, we don't have that quite that much. Okay, so our atoms are going to cancel, the units. I'm going to multiply across the top and multiply across the bottom and then divide. So I have 2.5 times 10 to the second divided by 6.02 times 10 to the 23rd, and I get 0.0415 moles. Let's look at another practice problem. How many atoms of sodium are in 0.75 moles of sodium? So I write my known from the problem. This time I have moles on top, so I need it to go on the bottom now, and atoms on top. 1 goes with mole, and 6.02 goes with atoms. My mole units are going to cancel. I multiply across the top and divide on the bottom. And I'm going to get 4.5 times 10 to the 23rd atoms. Okay, let's look at another one. Calculate the number of moles of CO2 that are in 1.80 times 10 to the 24th molecules of CO2. So I write my known from the problem. Molecules is on top, so it has to go on bottom here, 1 mole. And it doesn't matter that we were talking about atoms before. This number still works because it's just how many particles. So I have 6.02 again. So I cancel out my molecules, multiply across the top, divide on the bottom, and I get 2.99 moles. How many formula units of sodium chloride are in 5 times 10 to the negative third moles of sodium chloride? So I take my known from the problem and I write it down. Okay, moles is on top, so it needs to go on the bottom, and this time I'm getting formula units, which again is another option. It's just number of particles. So put 1 there, 6.02 on top, and multiply. My moles cancel, and I get 3.01 times 10 to the 22nd formula units. Okay, so we can also work this in compounds. Let's think about a car. Every car has 4 tires. So if you have a mole of cars, you end up with 4 moles worth of tires. Okay, so now if we think about that in terms of a chemical formula, we have sugar, which is C12H22O11. So if I have 1 mole of sugar, I actually have 12 moles of carbon because of the C12, 22 moles of H, and 11 moles of oxygen. So I can use that to find a number of particles within a compound. So how many oxygen ions are in 2 moles of aluminum oxide, which is Al2O3? So I start with my known. I have 1 mole of oxygen, and that's going to cancel. And I'm going to see how many moles of oxygen ions, which is O2. So for every aluminum oxide, there's 3 oxygens in there. So I'm going to put a 3 there. And then for every mole I have, I'm trying to get that to cancel as well. I want to get to ions. And again, it's number of particles, so it's 6.02. So now my moles cancel. I'm at the unit I want to end with. And so I'm going to multiply across the top and divide on the bottom. And I get 3.61 times 10 to the 23rd ions. Look at the next one. How many atoms of hydrogen are in 0.25 moles of ethanol, which is C2H5OH? So I'd take my known, I need moles on the bottom, and if I count, I need moles of hydrogen on top, and I have 5 H's and then 1 on the end, so that's 6 moles of hydrogen. My moles cancel. I need moles on the bottom here for H, and I'm looking for atoms, so I use 6.02. My moles cancel again, so I'm where I want to be. I just have to multiply it out. And I get 9 times 10 to the 23rd atoms of hydrogen.